Hello and welcome. We are going through Worksheet 2, Analysis of Linear Graphs. Let's get into it here. Number 1, graph to the right represents the relationship between exercise and sweating. Cool. They even give units down here. Check it out. So as I go and read any graph, I go, hey, that's exercise in minutes. Okay, 20 minutes, 40 minutes, 60 minutes, 80 minutes. And then the amount of sweating that we're doing, and it's measured in ounces, so fluid ounces in this case here, most likely. Although it doesn't say. And actually, ounces is one of the most frustrating units to me because there are fluid ounces and then weight ounces, so measuring volume, fluid ounces, and measuring mass, weight ounces, which is very confusing. But anyways, we don't have to worry about that in this problem. It's just ounces. What's the dependent variable? Well, the dependent variable is the one that you are not changing directly. So think about this situation. If you were going to try and figure out how much sweat you actually came off of your body while you were exercising, would you set how much sweat you're going to collect and then figure out how much exercise you're going to do for that? Or would you say, oh, I'm going to exercise for 20 minutes and then maybe I'll collect the sweat and just see how much it is? And you would say, oh, one of those sounds way easier than the other. And that is setting the amount of exercise that you're doing. And so then, therefore, the thing that you're setting, it would be very easy in this case to say, exercise for 30 minutes, let's say, and then we'll collect all of your sweat. Now, collecting the sweat might be hard in itself, but the idea sounds relatively simple, and it is. So that means that you are setting values for exercise. And the ones that you set values for, that is your independent variable, right? We said it was independent, or we describe it as independent because it was not dictated by anything other than the fact that we found it to be easy to set those values. And then when I set those values, let's say 30 minutes for exercising, then I'm going to go collect something and measure something else. And in this case, that's the sweating here. And so then these values on the vertical axis, or these values of sweating, depend, and so this is the dependent variable. And so then these values depend on, well, how much I was exercising in this case. So that's true for any graph. We, by definition, you might say, or convention really, we put the independent variables on the horizontal axis and the dependent variables on the vertical axis. So we know, and we're telling the readers just by graphing here, what values I set, totally random you might say, or just picked out of my head, those are the values that are down on the horizontal axis. And then the thing that I was measuring to see if it was changing or not was the dependent variable, the thing on the vertical axis. So then we could just write those in there. The independent one, I did that one first for no reason, exercise, or at least just to describe it. And the dependent variable was, in this case, sweating. Probably should say the amount of sweat collected. Are these variables direct or indirectly related? And check this out. Well, here, this blue line here is a line of best fit, or also known as a trend line. And the red one looks like that's the actual data there. Now, the red one, if you zoom in a bunch, looks like, well, there's a bunch of pixels there, so I guess it doesn't look like it was dots. I thought it was going to be dots. It should be dots, as when you graph anything, it should be independent dots, or the independent data points that you actually took there. But anyways, let's look at the line of best fit, or the trend line there. And we can see as I'm increasing exercise, as I go from 20 minutes to 40 minutes to 60 minutes, my sweat is also increasing as well. And so therefore it is a direct relationship there. And I got my writing it off there, direct relationship. And that's how I knew, because as one went up, the other one was going up directly, you might say, and that would make sense in this case. So what does it look like if it was an indirect relationship? Well, that would be like if the exercise was going up and the amount of sweating was going down in a way that was nonlinear. So if it's a linear relationship, if the line of best fit is a straight line, it's going to be a direct relationship. If it's a horizontal line, well, let's go ahead and do that. What if we had data that the trend line was a complete horizontal line? Now this would mean that it's neither direct nor indirect, but instead the independent variable would not affect the dependent variable. They're independent of each other. I don't think you'll see any in these worksheets, but that's true. Okay, so anytime it is a linear relationship, we know that it's going to be a direct relationship. So you can actually have exercise go up and sweating go down, and it still be a direct relationship if it looked something like this. If that's a straight line, it was supposed to be a straight line, there's a little bit of curves in my handwriting there, but if that's a straight line, a linear relationship, this is still a direct relationship. As I directly, let's say, double the amount of exercise, 20 to 40 minutes, my sweat might go down by half, or it might go down by a quarter. It doesn't have to be a one-to-one relationship there. Okay, let's keep going on. What is the value, unit, and meaning of the vertical intercept? Notice how they said vertical intercept, and they didn't say y-intercept. Well, you might ask, why didn't they say the y-intercept? Well, check this out. In math class, you're used to graphing things on the x, y coordinate plane. That's called the Cartesian coordinate plane. Now, you don't have generally in math class, you don't have real variables and real meanings to the numbers. And so we kind of, you might say, make up this x and y. We just use two generic letters or variables for that. Great. Well, notice the y, typically goes on the vertical axis, but doesn't have to. And then notice at this graph, we're not graphing y, the generic variable y on the vertical axis. We're graphing sweat. And on the horizontal axis, we're not graphing x, we're graphing a real variable, exercise. And so, okay, so that's first and foremost, that's why I said vertical axis, and that's why I say horizontal axis. That's the generic way to describe that. What is the value, unit, and meaning of the vertical intercept? Okay, so now let's go through the value. Well, it tells us right down here. That's easy. So the vertical intercept, we can't abbreviate sweating too well, so I'll say sweating subscript. Oftentimes we'll put subscript 0. So at time 0, how much is this variable here? Oftentimes, and I think we've seen this already, that we'll abbreviate one of the variables to something shorter. Sweating is not a typically seen variable, so we don't have a good letter that we use and substitute for that. But the sweating at time is equal to 0. If we put a subscript on things, that's what that means. Then we can see that the vertical intercept is 0.9411. What units are that? Well, that's in ounces because the amount of sweat is measured in ounces there. Now, what does that mean? That means that if you exercise for 0 minutes, if 0 minutes of exercise, you would still sweat that amount. I'm trying to abbreviate things here, still sweat 0.94, oh gosh, I combined the 9 and the 4, that was weird, 9411 ounces. So even with not exercising at all, you would still have that amount of sweat. And that actually kind of makes some sense because we're always perspiring. You take off your socks and shoes, you haven't even done anything. You could just be sitting there and you're like, oh yeah, they're a little bit clammy or damp maybe. And that's because we're always perspiring here. You could sit in a car with all the windows up for a while and it just start to fog up on the inside. Why is that? Well, again, we're always perspiring and there's some moisture coming from your breath there as well. What's the equation of this relationship? Well, two ways that we can do that. One, we can fit that to slope-intercept form here, and then I'm going to fancy physicsy that up a little bit, or sciencey that up a little bit. Here we have sweating, so I'm going to replace y with what variable it actually is, sweating. And then the m is the slope. Here's my slope right here, 0.0637. There's units for that. Remember, this is not just math class, but we have units with that. Well, remember that slope you always get as being a rise over run, if you remember that in math class. that particularly in math class is delta y over delta x, or you may have also seen it as y2 minus y1 over x2 minus x1. Notice the subscripts on those variables, same thing to the subscripts here that I was describing. Okay, so then how do we get the units? Well, we're doing the same thing here. If I was taking the difference of y values, that's the difference of ounces. And I would divide that by the difference of my x variable, which is, in this case, the unit of that x variable is in minutes. So then this thing is just ounces divided by minutes, just like when I go and put in those actual numbers. That's how I actually go to do that. And those numbers would have these units on it, so it's ounces per minute. No, that's easy. Okay. And then, so this whole thing is your m there. And let me color code. Well, yeah, let me try to color code that. I'm going to erase this bit over here. And I'm going to do that a little bit differently. We know it's m times x plus b. So now I got to put in my x here because it's m times x. This whole thing was m there. That whole thing in red there, minus the stuff on the left-hand side. Let me go redo that so that's color-coded too. That would be nice. Y, and then sweating. Okay, cool. Now this is coming together. M here is this whole thing, including the units there. I got to multiply that by the x variable. Well, check that out. My x variable is actually exercise. And so let's do that, exercise. And then I'll go back to green for the vertical intercept. And then plus my vertical intercept, that b value in math class there. So plus my 0.9411. Now careful, if I wrote down a number, I need to write down units, and that's in ounces, as we just said right up here. OZ for ounces. Cool. Predict the amount of sweat, or the ounces of sweat, at 110 minutes of exercise. Wow, check this out. We've already done basically all of the work here. So now what do I need to do? I need to take this thing, I need to plug 110 minutes in for exercise there, and grab my calculator and do it. And that's it. So that's exactly what I'm going to go do. So I'm going to take 0.0637. I'm multiplying that, and I'll write it out here too, 0.0637. I'm multiplying that by 110 minutes there, because that's exactly what it says to do, plus my vertical intercept there, 9411. And when I go and do that, times 110, you're doing that with me. Don't just wait for me to do it. Make sure that you punch it in correctly. And you get 7.9481, and that was the amount of sweat there. I know that's how much sweat because I just solved that for that variable there. And so I make sure that I put the unit of sweat, in this case here, in ounces. Cool. That's it. Have a wonderful day. See ya. Bye.